like that out of your textbook. In fact, I would avoid your textbook for the first few of these parts anyway, just because the way that they explain it is just a little muddy, shall we say. Trigonometry, or more specifically, what's called right triangle trigonometry. I'm sorry. Quizzes. I did not get a chance to finish those all the way out yesterday. I hopefully will get those done this evening. Today I was going to try and get most of them done during the third hour, but I wound up helping out Mr. Fontana because he was out today, so I wound up helping out in his classroom during that time. So I'm a little behind on them, so I'm sorry. Thanks, appreciate it. You're the best. Anyway, what I'm getting at with this whole idea of what we call trigonometry, right triangle trigonometry, I've always found that it's a very easy thing to explain when we're talking about perspective. And you guys have probably all heard this before. You ever heard that saying, it's all about perspective? Yeah. What does that mean? You look at something. That's how you look at it. It's about how you look at it. Now, when we're talking about this thing called right triangle trig, that means what kind of triangles are we working with? Correct. We're working with what are right triangles. And the way that I keep going back to this idea of perspective is that when you have a right triangle, you know two things right away. You know that you have, you know where the right angle is. You always know where the, what is? The hypotenuse. The hypotenuse. The hypotenuse never changes, no matter what. Your hypotenuse is always going to be the side length that is opposite your right angle. That's when we start looking at this whole idea of perspective here. No matter what I do to this triangle, no matter what I do to it, the hypotenuse always stays in the same spot. It never changes. It always stays across from the right angle, whether it's smaller, rotated, larger, gone here. If it gets flipped, it doesn't change. It's all the absolute same. Okay? So as we go around, we start saying, that's why we keep saying trig is about perspective. It depends on how you look at it. Okay? And what we're going to look at today is we're going to talk about a few steps in how we set up and work with trigonometry. And for the first few days or so, probably till next Tuesday we get back from the long weekend again, we're probably not going to press a single button on our calculator, except for one time today to show you what it does, at all. Because if we don't overburden ourselves with how to press buttons, and we just worry about how do we get to be able to press buttons, it makes everything so much easier in the long run. So I usually take a good 2 or 3 days of just pure setting up problems, getting X by itself, doing things like that, before I bother trying to type in all these string of values together in a calculator, because then it gets muddy. So let's do this. When we're talking about these right triangles, especially for today, you are going to be given some angle. We'll just call this angle 27. Okay? And I'm going to go through a list of steps that we're going to do to help us set up a trigonometry problem. All right? We'll say this is 8, and we'll say this is something we don't know. I'm just making up values real quick, just to get the ball rolling so you can see how this is going to play out. So whenever we get right triangle stuff, and in trigonometry here today, and tomorrow, and kind of for the next bit of time here, the absolute first thing we are going to do is circle our angle. And I just used a different symbol. First thing we're going to do is circle your angle. You know what that symbol stands for? Thank you. Yes, it stands for angle. You know what? All right, maybe rephrase that. Do you know what that symbol is? Copyright. That's good. I like that one. No, it's called theta. It's the Greek letter theta. The Greek letter theta is used to denote angles And you use that angle a lot more when you are using trigonometry as opposed to.
How do you believe in one thing? Oh, that's not
Okay. It's used. It means the exact same thing as angle, but a lot of times, whenever you get into what we're talking about today, this thing called trigonometry, you're going to see stuff written as what's called theta. Angle theta is 17. Angle theta is this. Means the same thing. Okay? Theta is used more as you get in upper level math. And since this is an introduction to trigonometry, I might as well use some of the terminology that you're going to see as you go along, whether it's algebra 2, pre-calculus, or whatnot. Okay? So what we're going to do is we're going to circle the angle, circle theta. Where's my angle? It is 27. So what am I going to do to the 27? I'm going to circle it. Okay. And you'll remember this next term here because I've been using it a lot with the 30, 60s, and the 45s. I'm going to draw an arrow to side opposite and label opposite. Remember how I've been saying all along, the 30 looks at a side opposite is x. The side opposite of 60 is x root 3. The side opposite of 45 is some value x. I was trying to get you guys the idea that the angles always open up to a side opposite. So what I do is after I circle something, I'm going to draw an arrow to the side opposite and call it opposite. Because no matter what, when I have a trig angle and I have that stuff, again, same idea. That angle always points at its opposite. That never changes because you are always opposite the side that you're looking at. No matter how it's shaped, how it's drawn, how it's done, that angle will always look at a side opposite. You okay with that so far? All right. We already did this one, but technically this would be the third thing that I would do. Is I would label my hypotenuse. So let's see, we have circle theta. 2 was draw arrow to side opposite and label hypotenuse. How many sides are on a right triangle? 3 of them. How many have we already labeled? Which means how many do we have left to label? 1. Okay. So when we're dealing with this stuff called trig, you have 3 sides. You have a side opposite. You have a side that is the hypotenuse. And then the third side is called the side that is adjacent. Which of those 3 haven't we used? And adjacent. So what do you think my next step is going to be? Label the last side adjacent. So label adjacent. And what's nice about that is the adjacent, if you're leaving that for last, by process of elimination, the last side has to be the adjacent. Well, yeah, in this case it's the next, yeah. Okay. So I would label that last bit adjacent. You with me so far? Now comes the fun part. Now comes the part that you don't know, you haven't seen yet, or probably worked on. So what I would do is maybe move down your notes a few lines and whatnot so we can talk about what are called the trig ratios, because that's what we're at now. As you go through the ideas of working with these types of problems, the first 4 steps for these things, oops, let me write that on here as well. My first 4 steps are always going to be the same. Actually, my 5th step is too. I'm going to label my adjacent. Now, what we need to do here next is choose a trig function. Hey, hey. Sure. Look, we got it. And this is what you don't know about yet. When we talk about the idea of choosing a trig function, we're going to have 3 of them that we use in geometry. You've seen these already on your calculators. You've seen them as there are 3 buttons. There are 3 buttons on there that have letters on them. There are 3 buttons on your calculator that say sine, cosine, and tangent. Yes, ma'am. Those are for different. Those are the ones that are so the superscript. We use those for later. We haven't gotten there yet. Today we're talking about just these buttons. These are ratios. You're right, Joe. So these stand for what's called the sine, cosine, or a tangent of some angle. Sine of an angle, cosine of an angle, tangent of an angle. And Joe, you just brought up the word ratios. What are ratios? It's the right way to spell it. They abbreviate it so it fits on a calculator. Joe, you said it was a ratio. What's a ratio? We've been working a lot with them. Fraction equal fraction. Fraction equal fraction. Very good. Thanks for bailing them out. So ratios. Remember, ratios are when you have fraction equal fraction. Well, ratios, when you're dealing with what's called trigonometry, are going to deal with the ratios of the sides. And each trig function has its own ratio. Okay? Each trig function will have its own ratio. And this again comes back into play the idea of perspective. So if I'm dealing with a right triangle, here's a theta, this was my opposite. My hypotenuse, my adjacent. The sine of some angle is the ratio of the sides, opposite, divided by the hypotenuse. So sine is always going to be the ratio of the sides, opposite over the hypotenuse. Cosine is the ratio of the sides adjacent over the hypotenuse. And tangent will be opposite over adjacent. Now, depending upon what information you have in a triangle, will tell you which trig function that you're going to want to use. Okay. And for us, there's only 3, sine, cosine, and tangent. You will, in Algebra 2, work with reciprocal functions and stuff like that, but that's not anytime soon. Alex, you want to grab that phone, please? Yeah. Thank you, sir. There's your opposite. Now, when you look at the different trig functions, sine, cosine, and tangent, Notice how the sine and the cosine both use what? Yeah, they both use the hypotenuse. What doesn't tangent use? Hypotenuse. Okay? So what we're doing here is, see how I've said label opposite, label hypotenuse, label adjacent? By labeling them, that is going to allow us to use our next step, choose. I choose. That was 25 years ago that Simpsons episode was out. That was 25 years ago that one came out. So you choose a trig function. You're old, thanks, jerk. When I'm here, what side am I looking to try and find? An adjacent. What side do I have a number for? Your opposite. So which trig function works with opposites and adjacents? Careful, go through your list again. Tangent. Remember, sine is your opposite over the hypotenuse. Cosine is your adjacent over the hypotenuse. And then tangent is your opposite over the adjacent. So when I'm looking at that, by labeling everything out, I know specifically which of these am I going to try to work with. I have the opposite given to me. I'm looking for the adjacent. I don't care about the hypotenuse. It doesn't matter to me for this problem whatsoever. So I know that I chose a trig function here. In this case, I'm going to use tangent. I write it out. Substitute in. And get x by itself. Okay? So you have these quick 6 steps. First thing, circle an angle. Second, draw an arrow to the side opposite and label it. Label your hypotenuse. Label your adjacent. Pick a trig function. Substitute and get x by itself. So what was my angle? What's my theta in our first example? 27. So I know that I have the tangent of 27 is, our opposite value was equal to, well, no, you have it labeled 8, and your adjacent is x. And that's what we're starting with today. We haven't gotten x by itself yet, but for right now, I just wanted to start with this. Okay. Now, for the first day and a half, almost 2 days worth of stuff, you guys are always going to be doing the same basic thing. You're always going to start with knowing an angle, which means you're going to try and find the side length. So if you really think about it, your variable for this stuff is only going to be in one of 3 possible places. You could look for an angle, a side, or one of the 2 sides. Today, you're only going to be trying to figure out one of the 2 sides, which means your variable, what you're trying to look for, is only going to be a numerator or a denominator, no matter what. Okay? No matter what. So what I do a lot of times with students is show them, since we know that these are just ratios, fraction equal fractions. Remember when we've done this? When I flip things around, when I do this, it doesn't change. Flip it back, it doesn't change. Things like that. Okay. It's the same basic idea. When we deal with it in terms of trig, it looks differently. You're either going to get this, or that. Your variable is either going to be in the numerator or denominator. The reason I wrote it as trig of some theta, because it's sine, cosine, or tangent. That never changes. It could be any one of those. You're going to have some angle value. You'll always have something there. So if you start thinking about how you're going to isolate a variable, How do you undo divide by a number? You multiply by a number. That's how you solve it if it's in the numerator. Okay. I multiply both sides by the denominator. Remember, if this was 4 equals x divided by 5, how do you undo that? You multiply both sides by 5, right? So you get 5 times 4 is x. The only thing that's different here is that this trig of some angle is a really crappy looking decimal that the calculator will do for you. You don't have to worry about it. What you're doing is just moving that around to isolate it to get it alone. Same idea with the other side. When you have something you're looking for in the denominator, we've done this before this year as well. Remember how we did exchange-o, change-o? We've done that. We've done exchange-o, change-o. We've done that. There's only 2 ways to solve these problems. There's only 2 ways to set up and solve for x for the first few days. You're either going to be in the numerator, x is in the numerator, or x in the denominator. If x is the numerator, you multiply out. If x is in the denominator, you exchange-o, change-o. It's every single time. It's either or. Trig of something is some x over number. You get some number times the trig of theta. I'll show you what it looks like numerically here in a second. There's a reason why we put numbers in front of trig values. That'll never change. Those 2 quick setups never change. Okay. So if I go back here, is my variable in the numerator or denominator? It's in the denominator. X is in the bottom. The x is in the bottom. So if I get x by itself, I exchange-o, change-o, so my answer would be x equals 8 divided by the tangent 27. Yes, sir. I don't want anybody pressing any buttons. Nothing. Okay? And the reason why I'm doing it this way, to start out, this is why I do this. Every year I do it the same way. I start out the first few days, no calculator whatsoever. Because if you start getting ahead of yourself with the calculator, if you start getting out ahead of yourself with the calculator, if you start getting out ahead of yourself, you're not knowing what you're putting down on your paper before you get to it. It's so easy to start screwing stuff up. That's why I require you guys to write down what you're putting into your calculator before you push buttons. Because even if you got to this part here, it's still really, really easy to type a wrong number. There's a lot of buttons that you have to press with trig. And if you don't have written down what you're about to do, and you just start pressing buttons, I won't have a clue as to whether or not you knew what you were doing. But if you write that down first and you get some weird number, I can tell that, oh, you hit sine of 27 instead of tangent. It's very, very easy to work backwards off of what you have versus what you don't. Okay? So as we get into this, that's what we're going to be doing over and over and over and over again. Okay? Let's try another one. Excuse me. So again, very, very, very first thing you're always going to do is what? Circle the angle. What's the angle here, guys? 47. Excellent. So we start by circling our angle. Second step, draw an arrow to the side opposite. So if I draw my arrow to the side opposite, it's down there, and I write opposite. Next, I label my, where's the hypotenuse? 12. By process of elimination, what's left? You have everything labeled. Now you choose the trig function. What trig function works with, well, I only have a hypotenuse and I'm looking for an adjacent. Which of the three has adjacents and hypotenuse? Cosine, excellent. So now I know that it's got to go to a cosine problem, so I write down what the ratio of cosine is. Cosine of something is adjacent over hypotenuse. Well, what's my theta? 47. What's my adjacent? Equals, what's my adjacent? X. Zero going here. That's why we label it. Is your variable an numerator or denominator? So, what's my final answer going to look like today? $12 cosine 47 is X. You're done. That's it. Nope. Nope. It's the answer. We're starting like this. We're not doing anything else. I don't want you to. Yeah. And the reason, and there's a reason why I put the number in front of the cosine value is, if you take your calculator out real quick, watch what happens when you guys press the button that says cosine. What opens automatically?
They have one friend.
They have one parenthesis. It is the same with the other ones. A lot of times what happens if you're not careful, we had what, cosine of 47, so it would have been 12 times 40, cosine of 47. Sometimes if you hit 47 and you hit times 12 and you don't realize that you're in the parenthesis, you're going to get a really, really weird number. As opposed to 12 cosine 47, if you put it out in front and you still forget to do your parenthesis, you're going to be okay. It's going to work out. It's like the mathicate that by putting it out in front, it's just a more common way. It's the same way that we did with radicals. Remember how we always put the number in front of a radical? It's the same basic idea. So don't worry about button pressing. I really don't care about button pressing. What I care about is, can you set it up and get me here? All right. I made a copy of a whole bunch of triangles so we don't have to continually redraw them. This might be easier for us to get through a couple extra examples. Let me show you.
No, I was trying to hit the, it wasn't sticking. We're not there yet.
I started on third. I don't know. I grabbed this one out instead. No big deal. Okay. So, right, starts on 13, guys. Sorry, apparently I grabbed the wrong one, but whatever. Doesn't matter. So, what's the very first thing you're going to do on number 13? Circle the angle. Where's my angle? 27. The angle is 27. Second step, what do I do? Draw the arrow to the side opposite. That's fine, that's fine. Label it. Opposite. Hypotenuse. Where's the hypotenuse? 13. By process of elimination. Very good. Next thing, it's going to ask you, what trig function do you use? Cosine. Cosine, because cosine deals with adjacents and hypotenuse. I write it out. Okay? Lastly, fill in the blanks and get x by itself. So theta is 27. Our adjacent is unknown. Hypotenuse is 13, which means my final result is yes, ma'am. Okay? I am not trying to do anything besides this for now because I have found over the course of two or 3 years, maybe, a lot more than that, the less burdensome you make this to start, the easier it becomes as it does become more complex. So the idea of understanding how to label and walk yourselves through a labeling process first makes everything easier. Okay? It makes everything easier. All right? Look at the next one. Actually, let's go to 20. I'm sorry, I got the wrong page. Go to 15. This is 15. First step, do what? Circle what? Which was the angle? Second step. The side opposite is the x. Where's the hypotenuse? Whoa! It's the hypotenuse is across from what? Across from the 90. So there's nothing here, but I still labeled the hypotenuse. The hypotenuse never changes, guys. The hypotenuse will always be across from the right angle. It'll always be opposite the right angle. 18 is the adjacent.
Money team.
Which trig function do you use? Okay, so you know it's going to be tangent. Fill in the blanks. Tangent 49 is opposite over adjacent. Again, your variable happens to be in the numerator, which means what do? There you are. Ladies and gentlemen, I know that we have had many types of problems over the course of the past week or so where it's extraordinarily procedural. Guys, I cannot stress, this is the time that you shouldn't try to come up with ways of doing things on your own. Follow the steps. It is so hard to screw up if you follow the steps. Don't put it past yourselves, but it'll be less likely if you follow them through. Okay. Let's go to 18. I don't know. We go to 18. First step, circle 25. Second step, draw to the opposite. What is the opposite? Has no value written on it at all. So what do I still do to it? Still call opposite. Where's the hypotenuse? And where is my process of elimination? Adjacent. What trig function works with for this one? Cosine. Cosine deals with hypotenuse and adjacent. So we have a cosine of something is adjacent over hypotenuse. Fill in the blanks. Cosine of 25 is 20 over x. Where's your variable this time? It's on the bottom, so what do? Perfect. You do an changeo, and get x is 20 over the cosine of 25. And you go on your merry way. Okay. Now, one of the things you may or may not have seen before is this. You've seen changeo. This is where it all came from. SOHCAHTOA. Sokotoa. Sokotoa is where all of the stuff came from. Sokotoa was an Indian tribe well before they were indigenous, before like even the Vikings and all that stuff came through here. And what happened was they were hunter gatherers, all that kind of thing, and they developed a way from taking angle measurements. And you know, you guys ever, you know how sailors crossed the oceans and all that stuff years and years, thousands of years ago by measuring angles of the stars? Well, the angles of the stars, the rotation, all that stuff, they were able to use what are called a clinometer. It's very similar to what they still use for surveying equipment. If you've seen guys looking through the little laser scopes, there's a guy out there with a pole, they're measuring angles and distances and stuff. It's rudimentarily, it's the same thing where they're measuring elevations and depression angles off of with regards to sun position. A lot of math. I wasn't there. But anyway, what they figured out from traveling and stuff like that, when they had to mark out specific lengths of plot lines and stuff like that, they were realizing that these ratios of the specific angles kept reoccurring. So they developed ideas of, all right, when I have these two values, this ratio occurs, and so on and so on and so on. It wasn't until the Greeks got involved with it that they realized that this is the sine is the opposite over the hypotenuse. Oops. Where cosine is the adjacent over the hypotenuse. And tangent is the opposite over adjacent.
So they were really
That's the easy way to remember where it comes from. Sokotoa, sine, opposite hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent. That's what those letters stand for. That's where they got it from. They were using the letters of their tribe, and they were just building it out of there to try and figure out an easy way to remember it. And then the Greeks just used to say, hey, this works. Okay? So what I want you to do with this rest of this worksheet, I think you got about, what, 7 more maybe total, because we've done like 3 of them, I think, is finish it. Again, do not use a button whatsoever on your calculator. Don't. Go through all of your steps. Make sure you have on your sheet of paper, whether you use Sokotoa, make sure you have sine of something is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. Your 2 ways of solving. Trig of something, x over a number, versus trig of something, a number over x. If you have these bits of information written on your sheet, as well as your steps, you're never going to get one of these wrong. Because every time you have a trig problem, we're going to do the exact same thing. And the quicker and the better you have yourself set up to start these things, the easier everything else becomes. Because again, it's all about perspective. It's all about what information you have and how you can label. And if you can label anything, everything else is just busy work. That's the idea. Can you label it out correctly to get you to the right spot? Okay? Oh, I didn't write out the last bit here. So your number. Oh, yeah. Sign? Yeah. Yeah, they're always, whenever I make these things up, I just randomly, I hit a button that says random, and I just try to make sure we get at least 1 or 2 of each style as you're going through. That way you understand how they all work. But if you label it, it's just pretty easy. Okay? We'll do more of this stuff tomorrow and continue on. Maybe we'll hit a button tomorrow. I don't know. But we'll hit a button tomorrow, or we'll worry about how do we set up our equations to solve for an angle. We might do that tomorrow as well.